My name is Stephen Brandon. I am from Brex. For those not familiar with Brex, we are a financial operating system platform where you can manage expenses, travel, credit, and so on and so forth. I myself am an engineering manager at Brex, and with me today are Fabiano and Michelle, and we're going to be talking about how we leveraged Amazon Aurora for building resiliency and expanding internationally, building our multi-region platform. And with that, I'll turn it over to them.
Hello, I'm Fabiano, and what is Brex? Brex helps our clients to spend wisely, and we do that through corporate cards. We also have expense management, travel, bill pay, and banking, and Brex help, as I said, help our clients spend smartly, but we all know that failure happens, and whenever a big failure happens, this will probably lead to not very happy clients. And to be able to not deal with this, to be able to help our clients to expand wisely, we are trying to prepare our infrastructure to disaster scenarios. And with that, next slide, please. Yeah, and when I'm talking about that, I'm talking about the data layer. Right now at Brex, we are using a lot of Postgres, and most of our connections are managed through PG Bouncer. And we also have replicas for applications and analytical purpose, things like extracting data to data lakes and things like that. So we have a mix of application use and analytical use. And we also have a specific scenario at Brex where we merge smaller databases into a single database instance, which we call nurseries. And this data layer, it's very sensitive. As any application, databases are very important. And in the past, how we handled disaster recovery scenarios, it was a very manual process. We would need to recover a snapshot in a different region. And as I said before, we have the nurseries, and the nurseries, they have a bunch of databases, which means that a failure in a single instance could lead to impact to a lot of applications. So our goal was to have a warm disaster recovery solution, and which would decrease the RTO and RPO for our current solution. And what is RPO and RTO? Next slide, thanks. RTO, I will just read the maximum amount of time it takes to recover to a normal operations after disaster. And the RPO is the recovery point objective, which is the maximum amount of data that we can tolerate to lose. Um, so here are some tips on how to determine your RPO, but this is what we did at Brex, but each company is different, so you need to take that into consideration. We basically look at our metrics and saw what we were capable of doing at the moment. And then we started noticing how much time we would need to recover from a scenario given the application that we had. And then we did a lot of testing. I think this is the most important part because you have to know how the applications will deal with the all the additional latency and not having the data. So having a lot of tests, it's very important. And you have to just based on that. And we decided to use Aurora Global because it was a solution that gave us everything that we need. And it's a solution that does not change a lot in our current scenario and add us the ability to use a secondary region whenever we need. And there are some caveats that we are using right now. We currently are creating our own custom DNS endpoint for reader applications. The ones that I said before, that they are being used both by applications and analytical purpose. So those go through custom endpoints that we create and we manage. But AWS provides a global writer endpoint, which means that you will have one single endpoint, and wherever your application is, it will use the same endpoint. So if it's another region, it will use the primary region. This means that you will always have consistency, which is exactly what we wanted to do. And yeah, next slide. And the harder part in this project was defining how we would migrate our current scenario. As I said before, we are using a lot of Postgres, and Aurora is Postgres compliant, but changing from one structure to another, it adds downtime to the application, because like you have to change the database. So one thing that we decided to focus a lot on automation. So instead of trying to handle this manually, we decided to build a temporal workflow. And temporal, it's a platform for running jobs, automated jobs. And we created this workflow that will validate all the steps necessary for the database to be migrated. And we pre-prepare the environment for that, and then we did the switch over, sorry, the migration to the Aurora Global after we were sure that all the automation has validated our database status. And one thing that for anyone that might want to do that, AWS has a very small window of downtime. It's just a few minutes. You have to use that to adjust everything in your infrastructure side. So these 2 to 3 minutes, which was the time that AWS needed of downtime that AWS needed to do the migration, is the time that you have to change all the endpoints and all the applications that are consuming this database on our side. And we leverage that, and Michelle will show you guys a little bit more about it. Go ahead, Michelle.
Hi everyone, I'm Michelle Koo, and I'll talk about how we use temporal workflows to automate this process. So before we started, we had our current state, which had a PG bouncer, so our application connected to PG bouncer, which connected to our Postgres instance and our replica instance. So in the process of migrating, what we did was we created the Aurora Read replica through AWS, and AWS will replicate the data to that for us, and that part was zero downtime. So we would start creating the Aurora replica like ahead of time before we want to do the migration. Once we were ready to migrate, then what would happen is our workflow would promote this Aurora Read replica and create this Aurora global cluster. So then at this point, then we would have like our application connected to our PG bouncer, which would then connect to our Aurora global cluster using that global writer endpoint that Aurora gives us that Fabiano was talking about. And then at the end, then we could create like another cluster and then we could have multi-region that way. So at Brex, we use Flux and Terraform. So we manage this a lot through Flux. So Flux is a tool for keeping Kubernetes clusters in sync through Git repositories. So this was very important for us in our migration validation process because the way it works is the workflow would generate these Flux Git pull requests ahead of time, and then the workflow would automatically merge them for us once we have checked them and manually verified that everything in the pull request looks good. And then we would send a confirmation signal to our workflow saying, yes, everything looks good. Please continue with the downtime to promote that Aurora Global Cluster. Um, Another thing is at Brex, we use Greptile AI, so that automatically will help us review our Flux PRs for us. It uses AI to like find any errors we might have in our pull requests or bring up things that we might want to look at in the comments. And lastly, we also created this dry run migration flag, which was really helpful for us. What this would do is it would basically run our migration without actually doing destructive actions. So in terms of Flux, it would create our Git pull requests ahead of time so we could look at them to see if they look okay, but it wouldn't actually merge anything and it wouldn't cause any downtime or promote the cluster. So this was a way for us to test our migration without actually doing anything destructive in migrating. Secondly, we use Terraform. So we created a Terraform template for how to manage these databases as a new global cluster. So we added Terraform for each database after the migration workflow completes. So basically the migration workflow would promote this and create an Aurora global cluster from the RDS instance. And then at the end, we would go through and add our Terraform template for this new global cluster that we created. And then also those reader instances that Fabiano was talking about are added and managed in the global cluster through Terraform as well. So at Brex, we have a Brex Cuddle command. So Brex Cuddle is our internal command line tool. So what we added was some commands to allow teams at Brex to self-service to switch over or failover for their Aurora global clusters. And this really allows teams to safely switch over and failover easily through this internal command line tool. So failover is used to recover from an unplanned outage. So if any of you remember what happened with US East 1 and that outage, so this would help with that. So at Brex, we actually use US West 2, so we were okay with that outage. But if it were to happen, in this case, we would use the failover to failover to a different region if one region's down. Switchover is used more for control scenarios. So like if we know we need operational maintenance or planned procedures, we would use a switchover for that and there would be no data loss. So here in the screenshot, you can see here how we have one global cluster and then we have two regions here, one in US West 2 and one in US East 2. So here we have a demo of our failover command with our internal command line tool. So yeah, so here we see our global cluster. We have our primary cluster in US West 2, and then our secondary cluster here in US East 2. So if let's say one region is down and we want to do a failover, what we would do is like we would call Brex Cuddle and then our DB failover command, and we would say which environment we're in. So here we're using in staging, and then the name here would be the name of our global cluster, which is up here. Yep, so once we have our command and we send it, it'll ask us a confirmation saying, are we sure we want to do a failover from like the one region to the other region? And then once we confirm it, it generates like that workflow ID. And if we were to refresh the page here, we can see that it kicked off the failover right away in AWS. So we can see that it's performing the failover, it's modifying one region's cluster and the other one. And what will happen is it should be switching the primary to the secondary. So like the secondary will become the primary. So here, oops, if we look at what it ends up being, so this is when it completes. So here we have our global cluster, and we can see that our secondary cluster is now US West 2, when before this was the primary, and now our primary is US East 2. So it was able to perform the failover. So next I'll talk about our iterative journey of improving our workflow performance over time. So when we first started this project, our main goal was to try to automate everything end to end. So if we have our RDS database, can we migrate it to Aurora Global? So when we first started, our entire workflow was around 15 minutes. So this was just our main focus was to have everything working end to end. And like we did have downtime to promote the Aurora Global Cluster, but at this time we also had downtime for creating those Flux Git pull requests and basically everything that the whole process required. So everything in this step was sequential. Next, we started adding parallelization to our workflow, and this brought it down to 10 minutes. So we updated the workflow to do some steps in parallel, including like fetching credentials we needed or creating those Flux pull requests ahead of time. At this point, we also added the dry run flag, which was really helpful. So this allowed us to test the migration on certain databases before we would actually migrate. So it wouldn't actually do anything destructive, but we could see those Flux pull requests created ahead of time. We could verify and make sure that everything was running end to end. And then finally, when we fully restructured our whole workflow after we did a lot of more experimental testing, we got the workflow performance time to 3 minutes. So now it'll only have 3 minutes of downtime, basically the amount of time AWS would take to promote that read replica to the Aurora Global Cluster. So some things that helped us get it down to 3 minutes is we create those Flux pull requests ahead of time now. So what happens is like we can start our workflow a day ahead or 2 days ahead, and it'll pause once it gets to the downtime. So in that time that we started, there's zero downtime, but it'll create these pull requests ahead of time, and CI/CD will run, and there will be no downtime for CI/CD. Secondly, we also noticed like those git add operations were expensive and kind of costly. So we basically reduced the amount of times we call git add until we had to actually open the pull request. And then lastly, like I said before, like we added that signal command to confirm and control exactly when we want to start the downtime. So now we have the flexibility of starting our workflow ahead of time, a day before. And then when we actually have our migration window, we can just confirm the workflow at that point and it'll start the downtime to just promote that Aurora read replica to the global cluster. So some lessons we learned through this process, we did a lot of thorough testing and deliberate deployment. So we really recommend keep testing and testing until you feel very confident before doing your first formal migration. What also helped with this too was we primarily did it on our staging environment first, and then before getting out all the kinks and everything before until trying production. Secondly, what really helped us too was automating the process. This really helped us reduce human error. It made it very easy to replicate the process for many databases. Like Fabiano's slide said, we had like 60 databases. This also allowed many team members on our team to participate and also run the workflow themselves. Third, we also recommend simulating migration as much as possible before doing a formal migration. So like what we added was like this dry run option to try to test the migration as much as possible without actually migrating. So this allowed us to create those Flux pull requests so we could review them ahead of time, make sure our workflow worked end to end. But we would basically skip over anything that would actually do the promotion or cause downtime. And lastly, iterative improvement. We did this iteratively over time. So we would migrate a few databases each week, keep a track of like what went well and what needs to be improved, and then made improvements before each set of migrations until we got to the workflow where it is now, where we got it down to like 3 minutes of running downtime. And yes, that's it for our presentation. Thank you so much for coming. If you have any questions or you want to reach out to us, please reach out to us on LinkedIn.